Welcome back. I hope that you're fine. In our previous videos, we studied different topics related to motion. In this video, we are going to study and derive the equations of motion. Initially, you might find these equations a little confusing, but you will find them easy as we move further. There are three different equations of motion, and these equations relate initial velocity vi, final velocity vf, time taken t, acceleration a, and displacement s with each other. These equations are related to the motion of a body traveling with uniform acceleration in a straight line. Students, you need to remember one more thing, which is very important, that in these equations, we are only taking the magnitude of displacement, acceleration and velocities. But why? Because these three physical quantities are vector quantities. We are not dealing with the direction but the magnitude of these quantities only. Let's jump to the equations of motion one by one. For the derivation, we need to make some assumptions first. Let's suppose an object travels with an initial velocity vi. After some time t, the final velocity of the object becomes vf. The distance travelled by the object during the time is s, and the object travels with uniform acceleration a during that time. While studying the equations of motion, you need to keep in mind that the terms displacement and distance are used interchangeably. Do not get confused if we use the term speed being used instead of velocity and distance being used instead of displacement. This is because the motion of the body is in a straight line. Now let's move on. If you observe the graph on my left, there are a few things that you might notice, but if you haven't, then you must take a look at them. First of all, you have time placed on the x-axis and velocity placed on the y-axis. As you can see on my left, the velocity time graph starts from a or vi. If you see a line AB, you can see that the velocity is vi. It means that the graph starts from vi. The body has some velocity before it starts. The body is not in a state of rest at a time equal to 0. There is some velocity which is called initial velocity, and it is represented as vi. The body here moves from point A to point B with constant acceleration a in time t. You can see a line here AB where acceleration a represents the line. Now let's start to derive the first equation of motion from the graph.